Hello, you are welcome. I'll be handling isometric projection using simple solids. In this particular video, we'll see how we can transform the orthographic view, giving orthographic view into an isometric view for a very simple solid. We have a hexagonal prism in orthographic view here, and then we have the front elevation. We also have the end elevation well annotated. Don't be confused with so many points you see all over. It's quite simple and easy to understand if you follow through. Now you would observe some things in the orthographic projection. You see I've created some points, or I've annotated the vertices of the hexagon with some points, 2, 3, 4, 5, 6, 7, and we have one here. This one here, you should notice, is going to be um, the lowest points, which I've already assigned here or marked out here in the isometric view. So we'll build up from that point. Now we would want to discover or want to obtain the other points 2, 3, 4, 5, 6, and 7. The dimensions are there. Between 1 and 2 we have 28.87. So I'll draw a line subtended at 30 degrees, a line subtended at 30 degrees that way, and that line will be 28.87, and I would quickly mark out that point right here. The next point you see is 3, and it has a distance of 86.6, also from point 1. So we'll draw a line from point 1 still, from point 1, 30 degrees, that would be 86.6. We'll also do well to mark out that point. Then I have point 4 this way. Point 4 is 50 millimeters from 1. So I'll draw a line. Draw a line, 50 millimeters. Don't be bothered about the platform I'm using. It's just for illustration. So I'll mark out point 4 there. Then I have point 6. Point 6, as you see, will also be 50. This is half. Will also be 50 millimeters from point 4 and 28.87 from that point. So we have what we'll do from point 4 here. We will mark out 50 degrees, or 50 millimeter, right? Rather 50 millimeter, and step out 28.87 that way, and we have point 6 that way. Of course, if you observe, you would observe that point 2 is the same thing as or point 6 is 100 millimeters above point 2. It's the same thing. So you could have drawn a line from point 2 upwards 100 millimeters. We'll do that for point 7. So for point 7, we'll draw a line 100 millimeters from point 3. We'll draw a line 100 millimeters from point 3. We have that. You will also see that point 5 is 115.47 millimeters from point 4. So we'll draw a line, and that will be 115.47 millimeters from point 4, like that. Now we have all our points. All we need to do is to join those points. So we'll quickly join the points using a line, solid line all through. So join the points from here to that point, from that point to that point, up to that point, up to that point, up to that point, and up to that point. So we have the front view of our model, or of our prism. From there we have the end view having a length of 100 millimeters. So what we need to do is to draw 30-degree lines from each of the points, 100 millimeters, and we'll do that. Start from point 2, 100 millimeters, 100 millimeters that way. We'll continue with point 4, 100 millimeters, point 5 or point 6. We will not need to do point 5 and point 3 because they will be hidden. So 100 millimeters and point 7, 100 millimeters, and we can join those points or the end points that way. And so we have our fully constructed hexagonal prism. We'll quickly move on to something a bit more intricate. We have a model that has some circular features. It's pretty much easy. In our class we have explained how to obtain a circular profile, or a circular profile in the isometric view. So what we need to do, just the way we marked out this point as our lowest point, is also the lowest point in our isometric view here. So we go over to mark out 100 millimeters. Subtended at 30 degrees. So 100 millimeter, we have that. Right at that point. So that's the 100 millimeters. We'll just go over to making, okay, well, there's this was not given. We'll quickly add the dimension from here to this point. That is 50. So we have 50. If that is 50, and the arc, if you notice, should also have a diameter of 50, the same, or 100, a diameter of 100. Of course, the diameter is the same as the length of this line, meaning the radius of the circle is 50. So it means the other half should just go all through that way. So we'll create the circle that bounds, or the square that bounds the circle. It should have sides of 100 millimeter by 100 millimeter. We have drawn 100 millimeter this way. We'll draw 100 millimeters upwards and close it up also with 100 millimeters. As I instructed, you don't need to bother about the platform we're using. It's just for illustration. So we have the square that should bound the the this arc. This arc. We're not going to draw the full circle. Yeah, full iso circle. We just need the top part of the arc. So we've marked out the 4 points on the iso square, or the square we have drawn in the isometric view. We would mark out the midpoints of these edges. Quickly mark out the midpoints of these edges. Yes. So we have the midpoints of those edges marked out with the circles. So join the we'll join the farthest crosses, farthest x's with a line that way. Then the shorter diagonal, or the shorter distance between the two x's, would join each of the x's, join this x to the circle you have there, or the midpoints. Join the second, or join that same cross with this circle this way. Join this cross with that circle that way, and join this cross with that circle that way. So you have this, and then we can now create our arc. Now, to create an arc from this circle to that circle, we'll use the radius from this point to that point. So with your compass on this point, and with your radius from with a radius of from this point to that point, and your compass, the iron edge or iron point of the compass right here, you draw an arc that way, like that. You see the arc that way, but for emphasis, we would use some more coloring from that point to that point that way. Then we need this other part of the circle. To do that, we would need the radius, or we use the radius from this point all the way to that point, and we draw our arc. So standing at this point and with that radius, so we have that way. So we now want to complete the circle. If we need to complete the circle, all you need to do is to stand here, just the way we did the first arc. You do the same thing here, and you stand here the way we did the second arc. You do that here. So we can now join the rest points that way, and that way. So you have that like that. So we would want to construct or develop the other side of the model by taking 100 millimeters down this way, taking it up 50, at this point. So all we need to do is to transfer this arc. We just need to transfer this arc by, and we can transfer that arc by getting a circle or a line, drawing a line at 30 degrees, 30 degrees that way, and 100 millimeters distance that way. When we've done that, we just transfer this arc. We transfer this arc by using the same radius, from this point to that point. You would copy, or you would construct your arc that way. Next thing, you would also transfer the second part of the arc by making a line 100 millimeters. I'll just delete that. So I'll make a line 100 millimeters that way. That way, we have the line, we have the point here. That's where the point is. We have the point there. So all we need to do is to copy this arc. Of course, this time your points, your compass, or compass point should come here, and with that radius from this point to that point, you complete your arc. So you have your arc that way, and you can complete the model by joining up that way. You have that. Now, in a similar fashion, you will have to construct the inner circle, using the same method by creating a square inside and then constructing. We would not want to go into that to avoid our work being rough. So here you have it, simple constructions. With this, you should be able to do more intricate constructions.